Let's not waste gigas and megas and start our lesson. Now that we know how to break vectors into their components, let's do the other way around. Let's see how we add back the components into one vector. Let's suppose I have this component and that component. Two components or two vectors, I want to add them into one. In other words, let's suppose I have a ball here, I pull it to the right, I pull it upwards, and I want to find a resultant vector, a vector that is equivalent to these two, that will make the same effect as if these two, like these two, do. Naturally, it's going to go this way. I want to know the magnitude of this vector and the direction. Magnitude f and the direction alpha. Now what's the idea to calculate this f and alpha? If we close a triangle here, let's call it fx and fy. Fy, this vector is exactly the same as this one in its magnitude, so this is also fy. And the f we get through Pythagorean theorem, which means f squared equals to fx squared plus fy squared. So f equals to square root of fx squared plus fy squared. If we want the alpha, with the tangent. Tangent alpha equals to always the opposite over adjacent. Opposite is fy divided by fx. So these two equations, with them we can find the resultant vector, or a vector that is equivalent to these two, that instead of pulling the ball here and there, we can just pull it here and we'll get the same effect. Now let's practice these methods. So first, let's see how we can solve this problem. I have two vectors. Let's say this is 8, this is 10, and there's a ball here. I pull it upwards with the force of 10, I pull it left with the force of 8. I want to know what will happen to the ball. What will the ball feel? So the ball will feel something in this direction. I want to know the length, the magnitude of this vector, let's call it f, and the direction. Always choose the direction, if you can, the angle with the x pole, okay? So I can call this alpha also, but use always the alpha next to the x pole. So what will be f according to our equation? It will always be fx squared plus fy squared, which means 8 squared plus 10 squared equals to, I need my calculator, so it's square root of 164 square root, so it's about 12.81. And if I want this at the angle, tangent alpha is equal to always fy over fx, and if you do so, you will always get the alpha beside the x pole, okay? So if we do 10 over 8, this is fy, this is fx, and in order to get the alpha, shift tangent 10 over 8, 51.34 degrees. So instead of pulling pulling the ball upwards in the force of 10 and left in the force of 8, we can pull it in the force of 12.81 in this direction with this angle, and the ball will feel exactly the same. This vector is called the resultant vector of these two. It's a vector that is equivalent to these two. It will do the same thing as if these two were to act on the ball. Okay, now let's do more complex exercises. I'll wipe it off. I'll just leave these two equations here. So we said f is equal to that, and tangent alpha is equal to that. So let's start practicing a little more advanced questions. Let's say I have these two vectors. Let's say this is a force of 10, angle 30 degrees, and this force is 15, with the angle here 50 degrees. And there's a ball here. I want to know what will happen to the ball. What will the ball feel? A little tricky, because we pull it here, we pull it there. It will go somewhere here or there, definitely not downwards, but we don't know exactly. So what we want to do, we want to find a vector. This is a resultant vector, which means a vector which is equivalent to these two, and it will do exactly the same as if these two were to act. So what's our method? What we're going to do? First of all, we're going to break all the vectors into their components. Let's start with this one. Like we did the lesson 2. We break it into x vector and into y vector. I remind you, who gets the cosine? The cosine is always the vector next to the angle. So this one will be 10 cosine 30, and this one 10 sine 30. Let's calculate them. 10 sine 30 is 5, 10 cosine 30 is 8.66. Now let's break this vector into its components. So it will have this component and that component. Who gets the cosine here? This component, because it's next to the 50 degrees, it's beside the 50. So it will be 15 cosine 50, and this will be 15 sine 50. Let's do the math. 15 cosine 50 is 9.64, and 15 sine 50 is 11.49. So instead of these two vectors, I have these 4 components of vectors. Now it's easier to do the math. What we're going to do is draw another drawing, and let's see what the ball is going to feel. Someone pulls it from here at the force of 866. Someone pulls it from here in the force of 1149. Who is going to be stronger? Where the ball is going to go? Naturally it will go this way, because this force is more than that one. By how much? So we go to the calculator and do that minus that. We take always the big minus the small. So it will be, exactly, so it will be in this direction, and the length, the magnitude of this one will be 11.49 minus 8.66, which is 11.49 minus 8.66, 283. Now let's see what happens in the y direction. Someone pulls it at the force of 5, another one pulls it in the force of 9.64, so it's 2 people pulling it up, so the ball will feel a force of 5 plus 9.64, because it's in the same direction. 5 plus 9.64, it's 14.64. Now I can add them back into one vector. How do I do it? With these formulas. If I pull the ball here at 14.64 and here at 2.83, it will feel as if someone pulls it like that. So if I want the magnitude of that and the angle always next to the x pole, the f will be square root of fx squared plus fy squared. 2.83 squared plus 14.64 squared, which is 2.83 squared plus 14.64 squared, square root 14.91. And the angle, tangent alpha, always fy over fx. Fy over fx. Alpha is shift tangent, 14.64 over 2.83. 79.05. Okay, let's say 1. 79.1 degrees. So, instead of pulling the ball for 10 here, 15 here in these directions, I know what will happen to the ball now. It will feel as if it was someone pulled it in the force of 14.91 in this angle, so it will go that direction. Another example, I'm wiping it. Example number 2. Let's say I have these forces. This one exactly in the middle, let's say 45 degrees. Let's say it's the length of this is 20. And this one, length also 20, but the angle is 20 degrees. And again, I want to know what is the force that will feel this, what this ball will feel, or what is the resultant force that will be equivalent to these two. Let's do exactly the same. We break this vector into its components. So it's the x component and the y component. Who gets the cosine? Always the x component. So I'll do 20 cosine 45. It's 14.14. This one will get the sine, so I'll do 20 sine 45. You will notice that it is exactly the same. And we talked about it in the last lesson, why it's exactly the same, because it's a symmetrical problem. There is no this force shouldn't be more than that one, or this one should be more than that one, because the ball, according to this force, should move exactly in the middle. Let's break this force into its components. So we'll have the y component and the x component. Who will get the cosine here? This component, because it's next to the angle. So I'm going to do in my calculator 20 cosine 20. 18.79, and this one will get the sine, so I'll do 20 sine 20. 6.84. Okay, so instead of these two vectors, I have 4 vectors which are components of these two. Let's add them up. And the x direction, I have 14 here and 6 there. Who is stronger? 14, of course. By how much? I'm going to the calculator and I'm doing 14.14 minus 6.84. It's 7.3. So this one is stronger, so the ball will feel something to the right at the magnitude of 7.3. What happens in the y direction? Also 2 different directions. Upwards it's 18.79. Downwards it's minus 14.14. So the ball will feel as if someone is pulling it upwards, because this one is stronger than that one, at the force of 4.65. That minus that. So what we did is, instead of these 2 black arrows, we managed to put these arrows on the axis, So instead of these two, I can use these two. It will be exactly the same. And these two, I know how to add into one. The resultant vector should be somewhere here. Let's call its length f, and the angle always by the x pole alpha. F will be square root of fx squared plus fy squared, which means 7.3 squared plus 4.65 squared, which is 7.3 squared plus 4.65 squared, square root 8.65566, doesn't matter. And tangent alpha is always the fy over fx. Fy is 465 over 7.3. So alpha will be shift tangent 4.65 over 7.3. 32.5 degrees. So instead of these two vectors, I can use this resultant vector, which is equivalent to these two, and the ball will feel as if it was pulled by 8.66 in that direction. One more. Okay, that was a telephone. I'll shut it down. I did. Now let's continue. Let's say I have three vectors. Let's see. One is here, force 20, let's say 30 degrees. One there, exactly on the y pole, let's say 30. And one here, let's a little less, like this. Let's say 20 degrees at 15. Okay, so I have a ball here, and I use three forces on it. Upwards at 30, like this 15, this direction 20. I want to know what will happen to the ball. What is the resultant vector that the ball will feel? Again, we break the vectors into the axis, into the components. So let's start with the 15. I have this one and that one. Who will get the cosine? This one. So I'm doing 15 cosine 20. It's 14.1. Now I'm going to do 15 sine 20. This one will get the sine, so it will be 5.13. So instead of this vector, I have these two. The 30, I don't need to break it because it's already on the y-axis, or y-pole. So I leave it. This one I have to break. So, again, x and y. Who will get the cosine? Always the vector next to the angle. This one. So in my calculator, I do 20 cosine 30. It's 17.32, and this one will get the sine. 20 sine 30. It's 10. And I wipe it off because these two are instead of this one. So what do I have now? I have these two all components. This one I didn't have to break it because it was already there on the y-axis. So let's add them up. Again, I draw it again. Let's start with the x direction. Someone pulls it at 14.1, someone pulls it at 17. Who is stronger? Of course the 17. By how much? So this one, this direction is stronger, so the vector will be here, and it will be 17.32 minus 14.1. So it's 3.22. At the y direction, more vectors. Someone pulls it at 30, someone else pulls it at 5, someone else pulls it at 10. So what will the ball feel? It will feel 30 plus 5.13, these two, I add them up, minus 10. and this direction will win because it's stronger than the 10. So it will be this direction, 25.13. That plus that minus that, because these are stronger than that. If that was, for instance, if this, instead of 10 it was 100, what should I have done? I should have written 100 minus that, and this was the direction that I would draw here. So I have these two components, or these two vectors. What I want to do now is add them up. So to add them up, it will be somewhere around here. Let's call it F, and the direction always with the x pole. So we'll call it alpha. So F equals to square root of fx squared plus fy squared, which is 3.22 squared plus 25.13 squared, square root 25.34. And if I want the alpha, tangent alpha is always the fy over fx. 25.13 over 3.22. So I do 25.13 over 3.22, shift tangent, 82.69, let's say 7. So this vector is a resultant vector of these three vectors. Another one. I'm wiping it. Okay. Let's say, again, three vectors. Let's say I have this one, 10, this one, 20, and another one, and this one, 15, angle 30, and the ball is here. Again, I want to know what will happen to the ball. A force, a resultant vector that will be equivalent to these three. Let's break it into their components. This one I don't have to break because it's already on the x pole. This one also I don't have to break. So the only one I have to break to its components is this one. So let's do the x and the y. Who will get the cosine? This one, because it's next to the 30. So I'll do in the calculator 15 cosine 30. It's 12.99. Okay? This one will get the sine, so it will be 15 sine 30. 7.5. So let's draw another drawing. Let's start with the x. Someone pulls it at 20, someone pulls it at 12.99, which is, let's say, 13. 20 here, 13 here. It's like the ball will feel this direction because 20 is bigger. By how much? It's easy to see, 7. In the y-axis, I pull it 10 here, 7.5 there. The 10 will win by how much? 10 minus 7.5 is 2.5. So instead of these three vectors, I can use these two. Now the resultant vector should be somewhere here, and the direction is always with the x pole, okay? So this is my alpha. F will be square root of fx squared plus fy squared. 7 squared plus 2.5 squared, which is square root of 7 squared plus 2.5 squared, 7.43. And tangent alpha is always fy over fx if I choose this alpha with the x pole. So it will be 2.5, this is the fy, over fx. So 2.5 over 7 is, shift tangent, 19.65 degrees. And again, I have a resultant vector, this one, which is equivalent to these three. Another one. This was example 3. Okay, I write 3, and I write the 3. Now we are example 4 or 5. It doesn't matter really. Let's do something a little more, I don't think advanced. Okay, let's see. Let's do something like that. More interesting. Let's say I have a force here of 10, a force here also 10, and the force here exactly 45 degrees, let's say 20. Okay. I want the resultant force. Now this problem is a symmetrical problem. So if it's a symmetrical problem, I can always use the way I showed you up until now, or I can use a different way. Let's do both ways. First way, like we did the other exercises, just for the practice. I have a ball here, I put it 10, 10, 20, I want to know what will happen to the ball. So, what do? First of all, I break the vectors into their components. This one, I don't have to break. This one, again, I don't. And this one, I do. And we know because it's in the middle, these two will be the same by the magnitude, the same magnitude. So, this one will get the cosine, it's 20 cosine 45, it's 14.14. This one will be exactly the same. If you do 20 sine 45, you'll see you get the same result. So, let's add them up. 10 here, 14 there, who will win? The 14, by how much? By 4.14. 14 here, 10 there, who will win? The 14 here, by how much? Again, 414. So the resultant will be somewhere here, not somewhere, we know exactly. But suppose we don't. And let's write the F and the alpha. The alpha always with the x, by the exponent. So F will be square root of 414 squared plus 414 squared. Let's do it. 4 squared plus 414 squared, square root, wow, square root as 5.85, about. Alpha, we know it's 45 degrees because it's a symmetrical problem, but suppose I didn't know, so tangent alpha equals to y over x, so it's 4.14 over 4.14, and if you do shift tangents, it's a 1. Shift tangent, you'll see you get 45 degrees. So this is the resultant vector, and this is the direction. Let's do it another way. There are 3 ways we can do it. Let's do, I'll show you another way also. Okay, let's do second way. Second way, I'll do it again. I had a 10 here, a 10 there, and a 20 here. It worked 45. Second way to do this exercise, we know it's a symmetrical problem. So we know that the resultant vector should be somewhere along this line. Why? Because there is no the x factor shouldn't be more than the y factor. If suppose it wasn't here, suppose it was there, that means someone pulls it here more than it pulls it there. But it's a symmetrical problem, so it must be exactly in the middle. So if we know that it's a symmetrical problem, instead of breaking these like that, we can leave this one because we know that it's already in the right direction and just deal with these two. Instead of breaking it, let's add them up. Let's just deal with these two. How do I add them up? add them up. We know if we add them up, the resultant of these two will be somewhere here, not somewhere, exactly here, 45 degrees. Let's call it, F, I don't want F because we used it, let's call it just for P. And P will be square root of Px squared, so 10 squared plus 10 squared, which means square root of 200 is 14.14. So P is 14.14. Now what do I have? I have a force this direction, 14.14. A force this direction, 20. Who is stronger? The 20. So 20 will win by how much? 20 minus 14.14. So it will be 5.86. And I know that this is the direction. I don't have to calculate the angle again. Because I know, because it's a symmetrical problem, that the direction will be somewhere here. If the P was to be stronger than this one, so again, it will be exactly on the same direction, but instead of downwards, it will be upwards. So this is another way to solve a symmetrical problem. Not like that, but like that. Let's show you another way to solve this problem. Interesting. Okay. Let's draw it again. It was, so it's the third way. 10 here, 10 here, and we have a 20 there, 45. Because we know it's a symmetrical problem, we know already that the answer should be somewhere along this line. We can do something different. We can change our x and y poles into these. Let's say this is the x pole and this is the y pole. And let's break the vectors into these poles. This one I don't have to break. Why? Because it's already on the pole. This one is 45 and 45. 45 and 45. Let's break this one and let's break that one. So, if I break this one, it doesn't really matter which one is the cosine because these two are exactly the same. This is beside, so it doesn't matter. Let's say this is the cosine, this is beside, so it's 10 cosine 45. And this one will be the sine, but it's also the cosine because it's the same angle. So it doesn't matter, it will be 10 cosine 45. So instead of this one, this vector, I broke it into these two components. Let's break that one now. If I break it, again, this is 45, everything is 45 here. So I break it into this component and that component. This one will be also 10 cosine 45, and this one will be also, sorry. I did it wrong. Again, I broke it. I didn't break it right. Again, it's a mistake. Everyone can make mistakes. So again, it's also a mistake. Okay, so again. So I had here a 10, and a 20. This is the x pole. This is the y pole. Again, and this is 45, 45, 45, 45. I didn't break it right. I'll break it again. So, when I break this 10 into the y and the x, this will be 10 cosine 45, and this one we said it is 10 sine 45. That was okay. This one I did wrong. I break it into this and that. I accidentally wrote this one. So this also will be 10 cosine 45. And this one will be 10 sine or cosine. It doesn't matter because it's the same cosine and sine 45. Now what do I see? I don't even have to use the calculator for the x because I see this one and this one are exactly the same, so that naturally going to cancel each other. So at the x direction, I don't have any force. At the y direction, let's add them up and see how much I get. It's 10 cosine 45 plus 10 cosine 45, because it's this one and that one, or sine, it doesn't matter, cos and sine are exactly the same. It's, every one of them is 7.07. So what do I have now? Let's draw it again. I have a vector here. This is not my axis now, it's this. I have here 14.14, which is that one and that one, and here I have 20. So what will be the resultant? The big minus the small. So the resultant will be this direction. 20 minus 14 is 5.86. So we saw 3 different ways to break this into, to find the resultant force of this system. Another one. Okay. Let's do another symmetrical problem. Okay, so it's 6 or 5. I lost count. Let's say 5. Let's say 6. Okay. Let's do another symmetrical problem, this one. Let's do this arrow, and that arrow. Let's say 50, 50, 50. Let's say 30, 30. Okay, no doubt it's a symmetrical problem because you see the x side doesn't have something more than the left side doesn't have any strong force over the right side, over the left, the right over the left, you understand me. So let's do it also 2 different ways. First way, let's do it like we used to do, because this is the main way, you should know it. So first we break it into the components. This one I break to this force and that component. Who will get the cosine? This one. 50 cosine 30, 50 sine 30. I break also this one. Here and there. Who will get the cosine here? This one, because it's next to the 30. 50 cosine 30, 50 sine 30. Again, I don't even need the calculator because I know that these 2 will cancel each other. So, at the x pole, I have no force. They cancel each other. At the y force, let's see. 50 sine 30, it's 25. 50 sine 30 is also 25. So what do I have? I have upwards. 25 plus 25 is 50. Downwards, I have 50. 50 and 50 also cancel each other, so I have the resultant is 0, which means that the ball that is placed here will not feel anything. It will remain with a force of 0. It's as if nothing touched it. Second way to solve this problem. This problem is more symmetrical than the other one. Let's see why. I will draw it again. I had a 50 here, and 50 here. Look at the symmetrical overview of this drawing. If this is 30, this is 60, this is 60, this is 120. If this is 30, this is 90, this is also 120. And again, this is also 120. So, if we look at it from here, we can close a circle over it, and let's look and see if one side must be stronger than the other, is stronger than another side. I see if the ball is here, it's round is symmetrical all way round. It doesn't matter which way you look, every side is equivalent to the other side, so the ball will not feel, it shouldn't feel here more than it should feel here or it should feel there, because it's symmetrical all way round. So by words, you need to write it down. The result will be 0 just by looking at the problem and understanding the symmetrical value that it has. Okay, this is another example. Let's do one more. Now let's do things with parameters, letters. Let's see. Let's say I have here f, 2f with 40 degrees. Let's say I have here 3f's at 20 degrees. And let's see here, I have exactly here downwards, again 3f's. And I want to find the resultant. The idea is, and you will see that a lot of problems you will get later on will have letters. You will have a coefficient and then a letter. It can be f, it can be a big thing like with the, instead of f you can find things like that, things like that, and all other kind of things, letters. It doesn't really matter. Why? Because don't use them. Look at the problem as if it was like this. 3, 2, 3. 20, 40. Solve this problem, and when you solve it, at the end of the problem, when you have the solution, just add the f to the coefficient, to the numbers that you will get, and then this will be the answer. So don't follow with the f all the time, get rid of it, solve it like that, and then add the f at the end. Let's see what we are talking about. Okay, again we want the resultant force that the ball will feel. I break it, this one and this one. This one will get the cosine, so I write 2 cosine 40 is 1.53. This one will get the sine, 2 sine 40, 1.28529. I break this one also, here and there. This one will get the cosine. 3 cosine 20 is 2.819, let's say 82. And this one will get the sine. 3 sine 20 is 1.026, okay, let's 03. This one I don't have to break because it's already on the y. So, let's add the map. I have 2.8, 1.5. The 2.8 is going to win by how much? I do 2.82 minus 1.53. It's 1.29. Let's see what happens in the y. I have 1.03 plus 1.29. They are both 2.32, but the 3 overcomes them, so it will be 3 minus that. 3 minus that is this direction, 0.68. Okay, so what I do now, the resultant will be somewhere here, the alpha always beside the x. So f will be square root of 1.29 squared plus 0.68 squared, which is, let's not write f because f is taken, let's write p, okay, something else, p, because I used f here there. So it's 1.29 squared plus 0.68 squared is square root 1.46, and tangent alpha y over x, 0.68 over 1.29, alpha is 0.68 over 1.29, shift tangent, 27.8. So the answer will be that the P is equal to, or the resultant force will be 1.46 F. At the end, just put the F next to the numbers. Okay, and the alpha will be exactly in the same direction, 27.8 degrees. So this is how we deal with problems that have letters or parameters in them. Okay, I forgot to write the number. Let's say it was seventh example, I think. Okay, I want to show you something else now, because we finished talking about breaking the resultant force, finding the resultant force. I want to show you another way. We will not use it much, but you should know it. So it's, let's say 8. Let's go with something simple. Let's say I have here 10, I have here also 10, with the angle of 40. And I want to find the resultant. We already did it, we know how to do it. Let's quickly do it again. And I want to show you another way of adding vectors. First way, we'll do exactly the same. We break it into the components. This will be 10 cosine 40. This will be 10 sine 40. Let's go to the calculator. 10 cosine 40 is 7.66. 10 sine 40 is 6.43. So, someone pulls it by 10 here. 760 here, so this will win by how much? 10 minus 766, 2.34. Upwards, it will be 6.43. Why? Because nothing pulls it downwards. So the resultant will be, let's say, F alpha. F equals to 2.34 squared plus 6.43 squared plus 6.43 squared, square root, 6.84 tangent alpha, y over x, 643, 234, 6.43 over 2.34, shift tangent,